All right, so let's look at the fifth problem from this Codeforces difficult contest. So what's going on here? They're warning us that the memory and time limits are kind of short. And then we have the actual problem. So we have some array, and you want to find out which elements of the array are a sum of some segment of the array, 2 or more. So what does that mean? So like here, 4 is the sum of 3 and 1. And 5 is the sum of 1 and 4. And 9 is the sum of 3, 1, 4, 1. Okay. 6 is 1, 4, 1. 5 we already talked about. Okay. And n is 8,000. So I see how to do this in n squared. The sum does not exceed 8,000. So I think we could do 8,000 in 1 second. So let's try that. So the idea is we're going to check if each element is special 1 by 1. And we're going to go through the segments of the array. And the idea is if your segment is smaller than your target value, expand it, grow to the right. And if it's bigger, then shrink to the left, right? Cut off the first guy. And so we can check any individual value in O of n. And it should be a pretty clean O of n. There's no there's a pretty simple operation every time. So I'm not totally sure if this is fast enough, but let's give it a try, I guess. Okay, so getting the input. And now we'll check all of the numbers. Let's see, what is the lower limit on n? 1. Special case n equals 1. So if the sum is too high, then add to the, or too low, add to the end. If the sum is too low, or too, sorry, if the sum is too low, add from the right. If the sum is too high, subtract from the left. Otherwise, we found it. So we found plus, and just print out the answer. Boilerplate at the top, do vector stood. So let's get the example. So if it's too small, then we have to grow. Debug 51040. Okay, so let's hope that this is fast, I guess. This is problem E. Cool. So it looks like that was good enough. Right, so again, we're just checking, so this is a special case when n is 1 because there's no segment of length 2 in that case, so this code doesn't handle it. And obviously, since there's no segment of length 2, the element can't be special, so the answer is 0. So otherwise, we're just going to check every element individually. It's kind of wasteful, right? We're not using any work. And so the point is that you can actually quickly find if there's some subsequence that sums to any given target. So here, the target is just the element. And so we're going to keep track of this interval. So it's right inclusive on the left, exclusive on the right is a good way to do intervals. So starting, with the first element and going, the next two elements. So this interval starts at 0 and 1, and so the current sum of the intervals 0 and 1. And so now we just walk through the array, sort of looking for our target. So if the sum is too small, or our interval is too small, right, we have this rule that the interval has to be at least length 2, then we need to add something to the interval. So we add something to the right, the next element. And if we're at the end at this point, by the way, we're done, right? This is how we know that we've checked everything. So otherwise we add. And if the sum is too big, well, there's no point in adding more, right? We need to actually take something away, and that has to be from the left side. So we take something away. We take away a start and increment start. And otherwise, we've actually found it, so just write that down. And so if we found the element, then we get a point. And so the answer is just the number of points that we got. And so the point is that this loop always only takes O of n time, because every time we're either incrementing end or we're incrementing start. And so each of those only goes up to n. So the whole loop must be only 2n iterations, which is much better than sort of the brute force where you would check all n squared intervals. And the point is that sort of at every step you can know whether or not you should grow the interval or shrink the interval. So it's sort of a greedy algorithm to find it. So that's the problem.